Okay, good morning, everyone. Thank you for joining us today. My name is Rakshana. I'm part of the math literacy program. And today we're hosting math games for the brain. So we're going to go ahead and show some game examples for everyone. And we hope you all find it as stimulating as we do. Just to start off, the objective for today is to explore these 3 math games, which we'll explain in our presentation today. And basically, the idea behind these 3 math games is really discussing the cognitive advantages of math puzzles and what this does for the brain, and how to interact with this in a way where you really get the most advantages out of these math games. So we are part of the math literacy program. We're a Sacramento State program out of the math department, and we offer math outreach on and off campus. So environments like this, we offer, real life math applications for community members. And we hope you guys all learn about math in a different way and find it as interesting and as fascinating as we do. So thank you for having us here today. So to start off, I'll allow Cody to take on over. Yeah.
Hello, my name is Cody. I'm here to show you a game called Skyscrapers. And so here I'm screen sharing the game. The game is online so that we can explain it and use it over Zoom, but this game can also be played in person with with a grid and actual pieces. So the object of the game is to place all blocks on this grid, which is 3 by 3. So here we have, okay. So can you see me on the camera as well? So I'm holding up the physical blocks. In person, we have a grid like this. Oh, sure.
Mike is at the top. Oh.
Is it hard to hear me?
Yeah, speak here.
Can you hear me better now? Oh, okay. Hello, can you hear me? Is it no? Okay. I'll speak up a little bit louder. Okay, there we go. All right. So in this game, do you want to show? Okay. Yeah.
You are blocking.
Oh, okay.
So just explain the thing I would say.
Okay. So we want to place each of these towers onto the grid in such a way that there's one of each kind in each row and in each column. So let's place the first one. Okay, so we've placed a tower that is 3 units tall in this corner. Now let's place another one and I'll show. Okay, so now we have a tower that has 2 blocks, that is two units tall. And then let's place another one. And now we have completed this row with one of each, a tower of each size. So the added element of the game is that when we look along this row from the side where there's a marking 3, the number 3, that means that we need to be able to see all 3 towers from that angle. So yeah, so the issue here that we have with this game is that we can only see one tower. The tallest one, the tower that is 3 units tall is blocking the other 2 towers. So if this were a city grid, a city with skyscrapers, and we were standing where that number 3 is, then we wouldn't be able to see all 3 buildings. So we want to fix it. Instead, let's order those buildings in the opposite direction. So let's place a tower that's only 1 unit tall. There, okay. And then the tower that's 2 units tall after that one. And the tower that's 3 units tall at the very back. Now, if I'm standing at this number 3, we can see all 3 towers. So I've correctly filled, or for now at least, I've correctly filled this row. Now let's try to complete the next row. The row, if I was standing at the number 1 right here, then I want to be able to see 1 building. So I want to place towers along this row so that I can only see 1 building. So let's say, does anyone have an idea of what building I should place in this first space here? It can be 1 unit tall, 2 units tall, or 3 units tall.
And overall, you're trying to place 3 of each.
Yes, 1 of each of them. I couldn't do all red buildings. Those are all 2 units tall. That would break the rule of the game.
I would say 3.
3, okay. Let's do 3 then. I'm gonna place it here. Okay. Okay,
And we have to have unique towers in each block, right?
yes, exactly.
So then the next one would have to be a 1.
Yes, that's correct, because if let me try and place a 2 and
Go ahead, you explain it. I'm sorry, I don't.
Yeah,
wanna-
no, that's
I
great.
think I've got it though.
You've got it. I just want to show that other people didn't see why we couldn't play. We wanted to put a 1 here because if I had put a 2, then I've broken the rule of the game in this column here. I have 2 towers that are 2 units tall. So we don't want that. So how do we clear that? Do I just click 1 and redo it?
Does it clear?
No, that's not
You
clear.
just click here and 1
Okay.
and then bring the.
Ah, okay. So yeah, so let's fix it. Thank you. All right. So then the space that's remaining, what should we put there? Into this
2.
square. 2, yeah, we don't have a 2 tower. So let's do that one. All right. Now we have 1 remaining row to fill. We have this, we don't have a number here to help us, but we have numbers here that if I were standing at the number 1 right here and I looked down, I should only be able to see 1 building.
We have to put the tallest.
The tallest, yes, which is good because we need a building that's 3 units tall in that column. So let's do that. And what about in this last space? If I was standing here on this number 3, I should be able to see 3 buildings. So the 1, yes, I heard the 1. Okay.
Mm.
Does it, all right, and we have 1 remaining building to place. So it looks like, can we place a 2 there? Let's see, we don't have any restrictions on either side to look, so, but if we place a 2 there, then we would have 1 of each, and yay, tells us that we did it correct, so. Okay,
So you only have rules for what you can see for 2 of each.
yeah, yes, it depending on the game, the numbers that are marked on the ground there could be less or more of them. They're just hints for how to place the blocks. The less you have of those, the harder it is. The harder the game is. Do we want to try another one? See another one?
Sure.
Let's go here.
Okay,
Maybe 1 more. Okay,
this one?
Yeah.
Okay, so we're gonna pick this one because as you can see, there are less numbers on the ground. So we have less guidance for how to place the towers. So I'm gonna ask the audience, what block should we place first and where? Anyone have any?
The lowest row would be 3, so it has to be 1, 2, 3.
3.
3
Yeah,
that way and 3 that way.
yes, exactly.
You can't see my cursor.
Oh, no. Yes, I
So in
can.
each row, it's a 1, 2, 3.
I see 3 this way along. I guess I've been calling these rows and these columns, maybe to clarify. So in this column, we need to be able to see 3 buildings looking if I was standing here. And if I was standing here, I need to see 3 buildings. So what should we place in this bottom left
1
square?
at the smallest.
The smallest, yeah, the smallest, the 1. All right, what about behind it in either direction? If we have to see 3 buildings. Let's try. Okay. So if we did a 2 there, then we need to see 3. So then the remaining block on either side would be 3.
Yep.
Oh, whoops.
You can use
Oh, it's
the
got to go behind.
Yeah, I was clicking on the wrong
the
spot.
other small
Ah,
one.
okay. So let's fill that out. But now our challenge is we now don't have any numbers to work from, but we have the rule that in every row there needs to be, and every column, there needs to be a
Unique.
of each, one of
Yeah.
each type. So let's see.
So you only have one place you can put a 3,
And where would that be?
right in the center.
Right in the center. Oh, yes, because there's a 3
On each,
corners.
Yeah. on the row and the column. Yeah.
Okay, so let's try that. All right, now what should we do?
Now it's solved.
It's not solved yet. No, I'm joking. Yeah, I see. We still have to place the other one. So where should we place in this middle row? A 1 left over.
Well, you're only missing 1.
1, yeah.
And
So
same
I
with the other, column, same thing.
1 here. Okay.
Mhm. Back.
Yeah, so I guess you're right. Once we've solved based on the numbers on the ground, then we just look for what is
Unique
each row.
space. Yeah.
Yeah. Okay, so then we have just 1, 2 left. Okay, great.
So pass it on
Okay.
to
Sure.
Yuksana for
Okay.
the, oh, sure.
All right.
Jumping Jeep.
So the next game will be Jumping Julia.
Sure.
Oh, yeah, right there. Okay, hi everyone again. So this next game is called Jumping Julia, and in this game we also work with the grid. Except this time we see that we have our column numbered 1, 2, 3, 4, and at the bottom we have a row going A, B, C, D. So we have a little bunny right here below the start sign. And then we can see in the bottom right corner here of our grid, we have a square designated goal. So as you can see, the design of this game is that we need to get this bunny from the start sign to our goal sign, but the numbers on each of these square grids indicate how many spaces you can move in either the up, down, left, or right direction. The only direction that you can't move in is diagonal. So if you guys see the number 3 here, what does that tell us about the number of spaces we can move? 3, that's right. Yeah, 3. So we start here at 3, and then as you can see, the game actually highlights for us in blue which square we can move to depending on the number of spaces. So seeing that right here is our goal, we want to end up at this goal square. Do you guys think we should move to the 3 squares to the right, or should we move 3 squares down? Down? I think everyone's agreeing down. So as you can see, I moved down. So now our bunny is at here at square 4A. And then already it's highlighted for us that the goal square is now highlighted blue, which means the only direction to go in is here. So that one was pretty easy. And if we move on to the next example, we can see that they switched the grid up for us a little bit. So the bunny still starts at the start grid, and then the goal sign is still over here at the bottom right, except now we start at grid 1. So we can either move 1 to the right or 1 down. So again, I'll let the audience pick out where they want to start. Let's hop 2 to the right. To the right? Let's try it. Okay. So I just moved my bunny to the right. And now we can move either 2 to the right to this 3 spot, or we can move 2 down to this 2 yellow spot over here. Which direction do you guys all think we should move in? This one really, this game, it needs a little thinking. If we move over here, we move 3, and then we'll have to move 3 in either direction, or we move 2, and we move either 2 in either direction. I think we should go, let's try it out. Let's just pick 2 to the right and see where we go. Okay, so I did 2 to the right and I landed on the 3, which means I either backtrack 3 to the left or I move down 3. So it looks like if I move down 3, I end up at my goal. So we win again. And then, so far we've been playing the 4x4 grid. I think,
I have a question.
yeah.
If you started on the upper left again and did 1 down instead of 1 to the right,
Yeah, so one
and then
cool thing
2
about, sorry, one cool thing about this game is I can actually undo. So I can actually start over and then we could
Okay.
play it your way. So here
okay,
we are
so
at the
I
1.
would do 1 down
Okay.
and then 2 down
And then 2 down
and then 3 to the right.
and 3 to the right. Perfect. So you guys see how it does matter where you move to, but the point of this game is that there's not just one correct way to do it.
Can I
So-
interject here real
Yeah.
I just want to interject here real quick and see if we notice why we were able to do almost the same exact thing, but we went down and right rather than right and down. And if you look at this game, you can see what we call in math a matrix, and it's symmetric about the diagonal. So because of that symmetry, if we had a solution where we went right and down, we will also have a solution where we go down and right.
Right, they are absolute copies of each other's.
Yeah,
Right.
exactly. Okay, that was all.
Yeah, sure. Thank you.
Number wasn't,
Sure.
but it's all 1.
Okay, so let's jump ahead to puzzle 4. And like Cody mentioned, let's try to look out for that symmetry. So I'll let the audience decide again which direction we should move in. So when we look at this tile, the number 2 indicates to us that we have 2 spaces we can move in. So we have either 2 to the right or we have 2 down. Maybe we can call out again which direction we'd like to start out with first. It looks like if I move 2 to the right, I land on 2. And then if I move 2 down, I land on 3. So there's a couple options here.
I think
What was that?
either way will work.
Yeah, so let's do 2 to the right. So now our bunny is at the 2 space and it highlights for us again which block we can move to. So it looks like I can move 2 down to 3. So if I do that, the game actually indicates for us there's nowhere left to move, undo or restart to try again. Yeah, so
You
I'll
have
click
to
on-
move 3 spaces then.
Yeah, so if let's start this one again, because this just showed us that there is blockades whenever we are playing this game. So how about instead of repeating that move, let's do 2 down and we land at 3. So as everyone can see, I moved down to the 3 block. So now I'm at 3A, and the game is highlighting for us that the next direction we can take is at block 3D. So if I take that move, I land at 2, and this is the next direction options for us. So as everyone can see, I can either move the bunny 2 up to square 1D, or I can move the bunny 2 left to square 3B. So I'll let you guys pick which direction.
Up.
It looks like everyone is saying left.
No,
Up?
I say,
Up? Okay, let's do 2 up. Okay, so when I did 3 up, it looks like we have our goal square highlighted, and that wins the game. So I know we did 3 up and it lands at the goal, but then again, there's like many options you can take. So we were at the 2 square, and I instead could have gone 2 to the left and then gone to 3 and then repeated the whole thing. So it's really just about taking the step and then thinking it out to make sure you complete. Yeah, exactly. It's all about making sure that you take the right moves that get you there the fastest. Do you want to show the other grids or? So this is the 4x4 grid. There's also other options for larger grids. If you click the settings sign, it has offers for 5x5 and 6x6 as well. So now we see we have 5 columns and 5 rows. So it's still the same game design, but now there's a lot more blocks to consider. So now our bunny starts at a block 4, which means, again, it could either move 4 to the right or 4 down. So which one should we go to? See, and the bigger it gets, the more considerations you have to take.
to me, it looks like both are possible routes.
Mm-hmm. Do you guys want to start by going down?
Sure.
Sure? Okay. So let's move our bunny down. We land at 5A. So now we land at a 2 block. So we could either go 2 up or 2 to the right.
2 to the right.
2 to the right. So landing there gets us at the 3 block, and it looks like it highlights that the only move we can make is to this yellow 2 block. So let's go ahead and click that. So now that I'm at the blue 2 block, I could either move to this green 1 block or this red 4 block. Which direction? Or this 3 block over here, sorry. So now we have 3 options we can move in.
I would go down.
Down to the 3?
Mm-hmm.
Okay, let's go there. And so now that I went down to the 3, it says that our only option is up to this 1 green 4 block. So
Well,
I'll go ahead and click that. And now it gives us even more options. So now we have this 3 block, 2 block, and a 4 block.
Left.
Left,
3.
yes. Let's go to the 3. And that tells us that we can move down 3. And then from this 3 block, we can move right 3. And then we're at our goal. So this one did require a lot of thinking and more moves, like everyone can see. So really, if you play around with this and then even move on to the 6x6 6x6 puzzle grid, it gets even more complicated. So you really have to think out the moves, and if you want to solve it in the least amount of moves as possible, it gets harder and harder each time. So this is my favorite one to play around with. I think this one definitely requires a lot more thinking. Good? Sure. Okay, so now we'll move on to our last game, the cups game.
I have a
which-
question. I have a question on
sure.
this game.
Sure.
So in looking at getting close to where the bunny is at the goal,
Right.
only the 1 square will get you in. the 2 doesn't move that way and the 3 is too big, right?
Right. So a lot of ways that some people might play is instead of looking at where you start off, look at the end goal and look at the squares around the end goal. And then from that you can tell, okay, well, the closest squares to the end goal which will get me there looks like that green one, or even that yellow 2 over here.
Exactly. And the 4 is
So-
too big and the 3 is
Right.
too big. So you
Exactly.
don't want those squares. I got it. Okay.
Exactly. See, that's a good observation. It's like thinking backwards to get you there in the best possible move. So
Always
this one,
think
yeah, this one's
backwards.
definitely a lot of fun to play around with. And then moving on to the next game, we have cup stacking, which Shane can then explain for us. Speak louder.
Okay. All right. Hello, everyone. My name is Sheng, and today right now we're gonna play the cup stacking game. The objective of this game is to have all the cups in one of the positions, and so you start with a number of nodes. Now we have 5 nodes, 5 positions, and each position we have 1 cup. And for each cup in one position, you can move one position to the right or one position to the left.
Which position they want to start?
Oh yeah. Which position do you guys want to start? You guys can pick any.
Yeah, you can pick any. So let's,
Okay.
And there's only, how many stacks can you do?
only 1 stack.
Only one on top of the other. Okay.
So right now, we have the cups. We can take any one of them and we can go over maybe 1 or 3.
Okay. And what do we want to end up with?
We want to end up in 1 stack.
And 1 stack doesn't matter order.
Doesn't matter order.
Just one single tower of cups.
Yeah, one
Yeah.
single tower of cups. Okay,
Right.
so let's do an example.
Yeah. So we can start with position number 2, and we can move 2 to the first position. And now in the first position we have 2 cups, and 2 cups means that we can either move to the left 2 or to the right 2. But since there's no position to the left, so you can only move to the right 2. And to the right, you see there's a position with a cup. You can only move to the spots where there's a cup. And now we have 3. And which move do you guys think would put everything in one stack?
5 on the 4 and then on to the 2.
5
on
over the 4,
but then we are stuck.
because 4 can only
Why?
move to the 2.
Because you have 2 cups. So if you
Yeah.
do that, show that,
And you can't move 2?
because there are
Yeah.
no cups there.
Yep, it's empty. No.
I don't understand. Yeah.
Oh, you can only move to positions where there is a cup. You can't move to places where, yeah.
Okay. So we'd have to unstack now.
Yeah.
Yep,
so undo.
unstack.
Could we put 2? Okay. Could we put 5 on 4 and then 2 on 5?
5 and 4, but it's repeating the same position because 3, you need to move to the right 3 or the left 3, and you can only move 2 to the right or 2 to the left.
Well, I was gonna unstack. We can't unstack, like
Oh,
put
yeah.
2 in the 5 spot and 1 in the,
Oh, unstack. Okay. 2 on the 5.
never mind. That's okay. I don't
Okay.
have it.
Okay, so maybe go back to
Yeah.
where we did, and then over 3.
Yep.
Okay, we are back there.
So from here, if you stack 4 to 5, then you see that you can move to the left, and thus you have a stack of all the cups.
And we can show that record here tells us we were able to stack everything in position 3. Let's try. How about we try to stack, is it possible to stack everything on position 1?
All right, an audience, do you guys want to pick a spot to start?
Okay, I'm missing one of the rules. You
Yeah.
can stack how many and still move that stack? 2 at a time, 3 at a time?
You can move depending on
Yeah.
how many cups are in the tower.
I have
Yes.
no idea what that means.
So like if you see this in a 3 position, you have 1 cup, right? So you can either move left or right, one position.
unit.
Yeah. And then if you stack it, then in the 4 position, you have 2 cups. So you can move 2 to the left or 2 to the right. But you can only move within the number of positions, which is 1, 2, 3, 4, 5. So
Okay, and you can theoretically, you can stack 5 on top of the 3 and move all 3 of them back to the 5 and then unload.
yeah, you can stack 5
Okay,
on top of, yeah.
But that might
5
be a roundabout. It might not be very efficient. Okay,
So that works.
Yeah, that works. Right there. Yeah.
well, that was an accident.
Oh, we can try again. Let's see. All right, which position do you guys want to start with?
So I want to
Yeah.
show.
Okay, so if you have 3 cups stacked, you can move 1 space or 3 spaces.
3 spaces.
3 spaces.
Thank you, that helps. Okay,
So you can move the number
you're
of
cheating.
steps you can move,
got it.
same number of cups you have in the stack.
Okay, this isn't my favorite so far.
Okay.
You'll get used to it if you do it one more time.
Let's try out
Yeah.
one more time.
Yeah, let's try position 2.
Let's see. Is there a way to stack the cups in position 2?
Okay, I would just put 1 on 2, 3 on 2, and then stack 5 and 4 and put that all together.
Like this? Like
Yeah.
5 and 4? Yeah. Yeah, there you go.
You got it.
You got it.
Okay.
Wasn't that hard?
Let's see, go to
I-
records.
Yep.
So
So-
far, we were able to stack in position 1, position 2, and position 3.
And we're
Let's
trying to
try-
make it all work. Okay,
Yeah, let's try on position 4.
I would do the same thing.
Exactly.
I would
Because
do 3 on 4, 5 on 3, and then 1 on 2 and move the 2 of them.
yeah. So you notice that if you solve one side, like you solve 1, 2, then you can solve for 5 because this is symmetry about the 3. Symmetrical about the 3.
So how can we get to 5?
Do you remember the steps to get to 5? Probably not, but right.
Let's see, now we want to stack on to 5.
Yep.
Well, 4 can go on 5.
We're gonna go on 5. Right.
But now would it have been more advantageous to put the 3 on the 4 and then the 4, 3 on top of 5?
Let's try that. Maybe undo.
Undo. Which one on the cups?
3 on the 4,
3 and the 4?
and then put the 4 on top of the 5.
Okay.
Oh, well, we
Oh.
Do
Oh,
that?
yeah, there you go.
Like that.
That-
No, no, we're trying to fill the 5 spot.
Yeah, because
Yeah.
we cannot
Yeah, you
go
can't
from
move.
4 to the right because we have 2 units to move because we have 2 cups in that stack.
Yeah.
Thought we did that before. Okay. I thought we moved multiple cups.
you could move multiple cups, but because your unit ends 1 to the right and you have 2 cups, you can't move the full 2
Yeah.
units.
Because there's no 6th position here. So you can only move to the left because there exists the second two to the left.
So go there.
And right here.
Is there a way we can do something?
Can we get to 5? If we have this position right now, like if I move back here, then the 1 couldn't move because there's no cups on the left side or the right
That's,
side.
yeah, we don't know those rules then. Okay.
Oh, okay.
Okay, so let's see, let's try again.
Yeah, let's try again.
So yeah, we are almost there. So where should we start?
And so we were trying to end up at position 5. So perhaps if you take a look at this, so if you look at position 2, yeah,
4 on 5.
yep, 3 and 2, and then since to get from 2 to 5, you need 3 cups. So you can so 1, 2, 3, and you got the final stack.
So we were able to stack everything on each of those positions. So now in math, when we solve one problem, then we ask another problem. What happens? Is it true if we have 6 cups? Is the process still going to work?
So you want to try just any position, try with any cup. Here, here. No.
Any places you all want to start with? Can we get the position 6? Can we stack the cups in position 6?
Well, couldn't you, within the rules of the game, put 1 on 2,
One
then
and
put the 2 on the 3, and then the 3 on the 4, and the 4 on the 5, and the 5 on the 6? No,
Oh,
want
because
to move those onto this one, onto the green,
under the green, okay.
onto the blue. No,
Oh, which one?
put the stack of 3 on top of the 4.
Oh, because the stack of 3, you have 3 cups, right? So we can
Right.
move to the right side 3. So there'll be the
Oh, it has to move in this on the number of cups. I didn't
Yeah.
know that.
yes.
so you can go here.
Yeah, it would be too easy otherwise. Yeah.
Yeah. And now you can do 5 to 4, and then you move to 6.
So in the last game, we saw that we can solve it for 3, we can solve it for 1 and 2, and the 4 and 5 will be symmetrical. What about here? We are able to figure out we have something for the 6th position. Can the same strategy going to work for the 1st position?
Can you use the same steps that you did for to get to the first one? Because you stacked the 6th one.
So we did from
Was it 2 to 1?
2 to 1, yeah.
Yeah.
And then 2, 3,
3.
and then 4 to, yeah,
Here.
yeah,
so-
that was the step.
So can we use the same steps, but sort of opposite to get to 1?
Isn't there more than one way to solve this?
Oh yeah, there's more than one way to solve this. Yeah, do you want to try getting to the first position?
Okay, I think you could do the 2 on the 3.
2 out of 3?
Uh-huh. Oh, so I was gonna do 4 on the 5 and then on the 6, but that wouldn't work because it would be not enough spaces.
Yeah.
5 on the 4,
5 on the 4?
6. Oh, that won't work. I want to put 6 on the 5, but I can't move it 1 at a time and 1 at a time.
No,
No, you can't do that.
Okay, then I screwed up. Okay,
no,
never
but
mind.
can we still do it if we move the, oh, wait, can you go back for
Oh.
here?
I can't do it.
Okay, we had.
There's
that.
2 on the 3 and 4 on the, yeah.
Yeah, can we bring the 4 and 5 onto 6?
Yep, and then we can,
Oh,
okay.
then you,
Yeah, then we will be
Yeah.
stuck, yeah.
yeah, we'll be stuck.
then 3 would be on that and we would have 2 spaces. Okay,
Yeah. Yeah, exactly.
got it, got it. I
Okay.
still don't like this game.
It's better if you have the cups on your hand. It's easier to see it that way.
Okay, let's try again.
Yeah. So, how about we start with 5 and 6? Where we will go about now?
Maybe to 4.
So if we move no 6 to 4, and then you see and then we move 2 to 3. You see that from 3 to 2 there are 2 positions. So you have 2 cups. That's sufficient to move to 1. And then from 4 to 1 you have 3 positions. then it's sufficient to move to 1. That way.
So we will transition here. Any question on this game? We will transition and I will show you a few other games that you can play. How it's going over there?
Yeah, they solved almost all of them except the middle.
Okay. 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 In the middle. Okay. I will show some few more games. Let me. Oh, thank you.
Yeah.
I will show you a few more games. Okay, so this game is about shading. We have some numbers and some grid, and we want to shade in a way so that in each row and column, we have distinct numbers without any repeats. So right now in the first row, we are seeing that we have 1, there are 2 2s and then 5 3, right? So I want to shade in a way so that in this grid, in the rows and columns, we have exactly like we have numbers so that there are no repeats. So let's see. And then we want to follow through the shading in a way so that the region remains connected. So we cannot block one section. We cannot cut off one section. So I will show you an example. So since there are 2 2s, let me choose to block this 2 right here. And once we do that, I can see that over here in the second row, I have which digit you see is repeating in the second row? 1. So I have 2 choices. I can either block this one or I can block this one. Do you have a preference which ones to block?
Well, you have 3 1s in the first row, so it seems to me you should get
In
rid
the column? Yeah.
column, yeah.
Okay, so yeah, we have to check for rows and columns. So maybe that's a good suggestion since we are looking into the first column. We see that we have multiple ones here, 3 1s. So maybe I want to block it, but still I have a 1 right here. So one thing I will show you here that second row is now good, but I see that in the first column, I have 2 1s. So if I do this move here, the rule is we cannot block adjacent cells. So I will check here and that will give me an error saying some shaded cells are adjacent. So I cannot block it adjacent cells this way. So that was not a good move. So let's see. I still have the 1. I still have, so maybe doing this is not a good move here. Maybe if I tried to block this one, and if I would have blocked this one, that might have worked, right? Because those are not adjacent. And again, I cannot block this one right here because then 1 and 3 will be next to each other. So far in the first row, I have 2 5 3. How about in the second row? Can we block any one of the ones here? Which ones I can block?
On the right.
This one. So right now in the third row, which 3 I can block?
Either.
Either, right? I can block either. Let's try with that. How about the next 2 3s here? Which one you want to block?
Bottom.
Bottom. Okay. What about the fourth row here? Is it good? 1 2 3 4 5, all distinct numbers. What about the last row? Which 2 you want to block?
The one on the left.
This one?
Yeah, you already have a 2 in that column.
Column. And what about the last column?
I would say,
We cannot block this one because those are adjacent cells. So it has to be this one. And we were able to solve.
but wait a
that.
minute, aren't we supposed to end up with certain numbers in the squares?
We are supposed to end up with numbers
That are
on the
unique.
rows and columns and no repeats. Yeah, those are
Okay,
unique
that's
to
all.
each
Okay,
row
I
and
thought we were
column.
supposed to end up
Yes.
with 5 numbers in each row and column.
Yeah. So here
Okay.
we just have to make sure that we are avoiding situation when we have cells which are adjacent. And also we want to avoid situation where we are disconnecting a region. For example, in the corner, you see 3 and 5. They are kind of alone by themselves. There is no way to go to them from the other sides. So we want to avoid those kind of situations. So this game is called the Hitori game. And you can play this, you can have difficulty levels, different difficulty levels. This one you see here is the easy peasy problem that you can try out, and you can play other variations of this game. So that was the 4th game I wanted to show you. Here is a site, it's called Math with Bad Drawing Games. And there are multiple puzzles that you can play with multiple players on the same computer. So there is this Prophecies game, there is Neighbors game, and this are really fun game, paper boxing game. You can play this online. And I will show you one more. This is the one we did last time. So daily they put out this game, the set game. So let me pull this up. So in this game, we have 4 rules. First of all, there are a couple of shapes. One is the diamond shape. One is the oval shape. And we have this squiggle shape here. So there are 3 shapes. How many different colors do you see right here? How many different colors?
3.
3, right? Green, blue, and red. And if you notice here, there are 3 different types of shading. We have striped here, bold here, solid, and then empty. So 3 different types of shading. And also, each one of them represents numbers. So for example, here, this one represents 1. There are 1 diamond shape. How many this one represent? The corner right, the bottom right corner?
3.
3. So
Oval.
3 ovals, right? So we have 4 attributes, 1 with the color, 1 with the shapes, 1 with the shading, and which one I'm forgetting?
Solid.
And the
number of items.
the number of items, exactly. So there are 4 attributes. So we have to select 3 cards to create a set, and a set is where you want to have all the attributes the same or all the attributes different for each of the categories. So let's take one example. Say I pick this one, and this one. Let's see. Maybe I take this one. Okay. So I just want to move this one. Okay. So I pick the diamonds, which is one of the shapes. And I pick like, so diamonds, all shapes are same. I picked 1, 2, and 3. That means the number attribute was different. And then shading the same, all solid. And what was the last one? Shading, number, colors different, and shapes are same. So all 4 attributes, some of the attributes are same, some are different. So that forms a set. Can you locate another 3 cards that will form a set?
How about the ones with lines? The diamonds and the 2 diamonds and the 3 ovals. Would that be it?
So yeah, so 1 diamond. So if it is 2 diamonds, then we have 2 shapes that have the same shape. But the third
Oh,
one
so
is
it needs
not.
to be okay, sorry.
Yeah. So, but this one, I think this one is, yeah. So let's check this one. We have 3 diamonds, 1 number, 3 different colors, and same shading. Okay. Can you pick one more? One more. You all are welcome to answer as well if you see.
So it's all of them have to be 1 similarity, 3 differences.
No, you can have the same. If it's one, you are looking into one attribute, it can be all same or all different.
Okay.
So you have to check for each type.
And can you repeat the designs you've already selected?
So yeah, you can repeat. Yeah, you can repeat the designs. So anyone see any other set?
That's it?
Yeah.
Oh, okay. The top left,
This one?
yeah.
This one, okay.
Oh, no, you selected the red one. Yeah, can you unselect the red one? Because you selected the red stripe,
Oh,
this one, the red
this one,
diamond?
this one,
No, the red empty diamond, yeah.
empty,
And,
okay.
And the green filled diamond?
So we can see that Sheng is saying those 3 will form a set because I have shapes are all diamonds, but the shading is empty, solid, and striped. Colors are all different, but the numbers are the same. So that will form. So this is the game of set, and this is available online. They keep on publishing this every day with a different arrangement of the cards. And they also provide the solution from yesterday. So if you want to solve it today, you can go back and check the answer tomorrow. And we have one more. So that's the game of set. So bringing us to the end, we want to talk about the benefits of math puzzles for the brain. So we know that brain change across the entire lifespan with the creation of new brain cells. And when we are struggling or thinking about some math or puzzle, that makes new connections between brain cells. And so this is what neuroplasticity is, the brain's ability to change and adapt due to experience, including structural changes due to learning. And math games helps us through reinforcing existing connection between brain cells that creates new connections, delay the onset of dementia, produces dopamine, enhancing mood, attention, and concentration, and stimulates the prefrontal cortex. And here are a few other games for active minds. There are online bingo, word puzzles, Sudoku, logic puzzles, and the games we showed today. And that brings us to the end of our presentation. Thank you so much for playing with us today. And thank you everyone here for joining us online and being here. Anything else you want to say?
I think I enjoyed playing them. Even right now, I'm learning about them, so I hope everyone else does too. I know the cups game was actually the one I struggled with the most. The cups game, is the one I struggle with the most in person. And then I think online games are a lot of fun too. But it does turn challenging too, especially the Cups game online. Some of them are harder to learn, but at the same time, the harder it is to learn, it's like the more rewarding it is. Cause I'm forcing my brain to understand it. So that's the reward in it, I guess. So.
Anything you want to add, Sheng?
Oh, I thought today was really fun. The new game to me was Skyscraper. I didn't know how to play that one. And then they showed me. I thought it was really cool.
Cody, do you want to share anything?
Just here, let me come over there.
Yeah.
I shared it with them before, but just I like to always add a little bit of math. But the cups game is really cool when you play with 6 cups or an even number because you have symmetry involved. So if you find solutions to one side, the 3 on the side, you can use symmetry and perform the same moves to the other side. So that's something that math can help with when we have tasks like this game. Using a little bit of math can help us solve it faster.
And geometry comes in talking about the symmetry,
Yes.
how you do in on one side and you can follow the same steps to do it on the other side.
Right. Yeah.
So thank you so much. Any questions?
Did you refer us to the websites that we could use those games?
Yes. Is it helpful if I just put them in the chat or I can share those with?
That would be great. Yeah.
Okay, let me do that. Let me stop share. Let me put those in the chat. Let me stop share and I will put it in the chat. So the first one is the set. Okay, so that's the set game. And then I will put the next one, which is the math with bad drawings. And then I will put the next one, which is the Hitari game. And then I will put the cup stacking. And I will show you another website. I will put the link there. So that's the cup stacking. And the next one is the skyscraper. And the last one here is the Jumping Julia. Jumping Julia. Okay, and then I want to show you this one quickly. Let me share my screen. So this website you can simply type in JRMF. And this website, this is Julia Robinson Math Festival. They have lots of puzzles and those are from, anyone can use the game and the app. And these are for all ages and you will find some of the games, most of the games are really interesting and it requires some thinking. It is low floor, so easy to get into, and then you have to think a lot about the strategy. So I will put that link as well. Okay, so those are all the links. I put it in the chat and I will share those links with Linda as well so that she can send out an email with those games. We can.